सो हेलो गाइस, कैसे हैं आप लोग। आई होप कि आप सभी बढ़िया होंगे। आज हम शुरू करने जा रहे हैं चैप्टर 10 लाइट रिफ्रैक्शन लेक्चर 4th रिफ्रैक्शन थ्रू स्फेरिकल लेंसेज। आज हम बात करेंगे इस टॉपिक के बारे में, व्हाट इज़ लेंस, इसके टाइप और आगे डिस्कशन करेंगे सम इम्पोर्टेंट टर्म्स रिगार्डिंग इमेज फॉर्मेशन। ठीक है, फर्स्ट क्वेश्चन निकल के आता है व्हाट इज़ लेंस। A lens is a transparent material medium bound by two surfaces of which one or both are spherical. Example: spectacle, magnifying glass, binocular. Next topic: types of spherical lens. Two types of spherical lens: convex lens, concave lens. Let's define them. Convex lens: the lens which is thicker in the center and taper at both the ends is called a convex lens. In this diagram, point A and B is taper and it is thicker from center. Now it's turn of concave lens. The lens which is thinner at the center and thicker at the ends is called a concave lens. In this diagram, PR and QS is thicker and lens is thinner at center. Let us know some basic term regarding image formation. Firstly, optical center. What is this? The center of a lens is called its optical center. You can locate the optical center of a lens by joining its end by a vertical line passing through its center. It is denoted by O. See this: convex lens, concave lens. You can see O, center of lens, in these figures between A and B and X and Y in convex and concave lens respectively. You can also see written A and B points and points X and Y. What these points represent? These points represent aperture of lens. Now what do you mean by aperture of lens? Let's define it. Aperture of a lens is defined as diameter of circular edge of lens. In this diagram, AB and XY are aperture of convex and concave lens respectively. Now what is center of curvature? Center of curvature are the center of sphere whose part form the spherical surface of the lens. I think you understand. Now again let's know what is principal axis. It is an imaginary straight line passing through center of curvature of both the spherical lens surface, can be extended on both sides infinitely. These terms are same as we study in mirrors or image formation in mirrors. Let's move to new terms. We know lenses have two spherical surfaces. They have two principal focus. Let's define first principal foci, your focus of convex lens. The position of a point object placed on principal axis of convex lens for which the lens forms an image at infinity is called first principal focus of convex lens. I think it's complicated. See this diagram carefully. In these figures, you see that object is at f1. The rays of light from this object become parallel to principal axis and make image at infinity. See the diagram carefully. I think it's clear to you. Now move on to the term second principal focus of convex lens. The position of image of a point object placed at infinity due to refraction through a convex lens is called second principal focus of convex lens. Let's understand it with the help of diagram. See this diagram. Incident ray parallel to principal axis coming from an object placed at infinity forms point size image of object at f2 on principal focus. Now let's talk about first principal focus of concave lens. The virtual position of a point object placed on the principal axis for which the concave lens forms an image at infinity is called first principal focus of concave lens. See this diagram. The incident ray coming toward the lens, which tend to converge at point f1, become parallel to principal axis on refraction. Through the lens, this forms an image at infinity f1. Thus, the virtual position of the point object whose image is formed at infinity. It's turn for second principal focus of concave lens. The virtual position of image of an object placed at infinity on the principal axis of concave lens is called second principal focus of concave lens. Read these things carefully. See this diagram. Incident ray parallel to principal axis coming from infinity are refracted through the concave lens and diverge. On extending them backward, we find that they appear to diverge from point f2, which is the second focus of concave lens. Now it's clear that converging lens is convex lens, diverging lens is concave lens. Also, f1 always equal to f2. Focal length from first focus equals to focal length from second focus. If my video is good for you, please subscribe. It's very hard to make this type of video. Thanks you. See you in next video. Bye bye.